Now let's suppose we do have capital rationing. So this will be the optimal capital budget under capital rationing. We're going to have project, cost, NPV, and then a helper column called include. So we'll have A through M. So there will be a little bit of typing here. Whoops, that's not going to work. That's okay. Then down below we'll have our total and then our capital constraint. So cost will be 237,005, 766,496, 304,049, 565,178, 108,990, 89,135, 795,664, 814,493, 480,321, 826,610, 734,830, 910,598, and 978,621. Go ahead and total that up. Make sure this is 7611990. Good. Constraint will be 3 million. NPV is 84,334, 26,881, 23,162, 82,598, 20,590, 94,04, 18,163, 97,682. 52,063, 53,911, 56,323, 88,349, and 69,352. This, I'll now drag this across for our totals, 763,812. And currently for include, let's just put 1 in there to get going. Okay. So if I had no capital rationing because all these were positive NPVs, I would accept all projects A through M. But I have a constraint. So how can I decide which ones to choose? Some companies will just do a profitability index measure and then pick those. But we're going to use Solver to do that for us in this case. What will be the best ones? So, going to go to Data, Solver. If you do not have Solver, that's go to File, Options, Add-ins, Manage Excel Add-ins, go, and check the Solver box. I'll now click Solver and put in the following parameters. The objective is C17, that total. We want to maximize it. We're going to do so by changing D4 to D16. And then with B17, we're going to add some constraints. So our first constraint will be that B17 is going to be less than or equal to B18. We'll add that. Then our second constraint is that D4 to D16 are going to have to be binary, meaning 1 or 0. I'll click OK. You may say to yourself, well, wait a minute. If the objective is B17, none of those have been kind of linked together, and you're exactly right. So let me close this and change the total to be equal to the following function. So, in cell B17 to get our total cost, this will now be equal to the sum B4 colon B16 times $ D4 colon $D16. You could also view sum product. I'm going to drag that across to include NPV too. Okay. So now I'll click Solver, and now let's run it and see what happens. So now Solver has found a solution that is not right. Let's see. Let me cancel out of this real quick and go back to Solver. Okay, so for this one, if you do G or G nonlinear, that's for smooth nonlinear. We're actually going to change this to be simplex LP, since this is a linear solver problem. And let's click solve again. And we still get 4. So let's cancel that again. Go back to solver. Sometimes with the solver settings, you have to change some of your options. So with simplex LP, we pick that. We're going to click options. And we're going to set the max time to 100 seconds with 500 iterations. So let's click OK. And then we'll make sure that all the, we're going to ignore the integer constraints is not checked. So actually, let me go back to options. And then we'll set the integer optimality to 0. Click OK, and now we'll solve it again. So we'll take some time. And now we've got something that's very close to the 3 million R constraint. And this is what we want to save. Now you can save the scenario into like a scenario manager type thing. You could change the constraints, increasing or decreasing the cost. And that'll help you to decide which projects are really really important for you. But at least at this stage, you can see that A, C, F, I, L, and M were selected. Now, depending on your version of solver, you may have instead got A, C, D, F, H, L. That would also work, but this kind of just gives you an idea of how you could go about attempting to solve this problem with using solver.